Hello, my name is Jason Rose, and I'm going to lead a quick walkthrough of the user interface for the BioAssay Research Database, or BARD. The power of BARD lies in providing structure to assay data and metadata using controlled vocabulary. From the front page, you immediately see a search bar from which we can query projects or experiments based on terms from the BARD dictionary. As you'll see in just a second, you get a autocomplete menu which appears and shows you all the possible matches that are in the database already. So here I entered RAS, and I'll select where it's in the database as a Go molecular function term. I can select this, and that'll bring me to the search results page. From the search results page, we have the option to further narrow our results using various filters, like you would see on a website like Amazon. Or you can also view your results by clicking through these four tabs. The Compounds tab is fairly self-explanatory in that it shows compounds indicated as hits in experiments related to the search term. Assay definitions, projects, and experiments, however, those are the highest level terms regarding metadata in BARD. And so I can explain that further from the project results. So having selected a project from the search results, right away what you have is the name of the project. You get some top-level clerical information like who was working on it last. You get a brief description. You get the center that ran it. Farther down here you get any probes that might have resulted from the project, some more information, grant number, PI name. And but for our purposes, what we get down here is this diagram which best illustrates a project. And what is that? Is a project is a collection of experiments. It's a set of experiments which were run with a particular biological goal in mind. And so this diagram illustrates how the experiments which comprise this project relate to each other. So here you see we started with a primary screen, we moved on to a confirmatory screen with those results, had some additional counter screenings, secondary screens, more confirmatory, so on and so forth. And so this diagram shows how the experiments in this project relate to each other. And additional to that, what you have is this color coordination which reflects assay definitions. And so each experiment is an instance of an assay definition, which is to say a protocol. It's a set of metadata describing what was actually done in the well on this experiment. And so each experiment contains a set of data which is the result of having run the actual experiment described by an assay definition. And similar colors, or I should say identical colors, were exact same assay definitions. So you can see here both this confirmatory and all these confirmatories and secondaries were run under the same assay definition, but they were run with different sets of compounds and at different times, and thus required being broken up into these different experiments for the sake of describing the project better. So in order to explore the assay definition for a particular experiment, we can select the experiment just by clicking the box and then clicking this link next to assay definition over here in the box on the right. And so this will take us to the assay definition page regarding this particular experiment. And so again, the assay definition actually provides the context in which an experiment was run. It provides most of the information you would get from an actual in-lab protocol. So you get to the page and you can look down here, and each of these boxes provides a context, and then each of these items is a context item, and each of these items is constructed with terms from the BARD dictionary. So here you're saying the format context for the experiments running under this assay definition is it's a cell-based format, and you're using a reporter gene as the assay type. And so you can look down here, you can see about which kind of plate we're using, we can see how we're detecting activation, we can see the different components that were used, and each of these cards provides a different context. Then at the bottom, you can see a list of the experiments, and as I said, the beauty is the assay definitions can be used multiple times. That way you only have to write one assay definition, just like you would only have one protocol, and then each experiment is a different run. You're using a different set of compounds, you're getting different results, perhaps you're using a different threshold of activity. And this way, not only can assay definitions be conserved across multiple experiments, they can even be conserved across multiple projects. This way, a center, for instance, if they were running 10 projects, and each of them were running a similar idea but had different targets, you could use the exact same assay definition for the primary screen for all 10 projects, and you'd have 10 experiments, 10 different projects under one assay definition. And it's a way of consolidating all of your data. Now, when you're looking at an assay definition which you own, you can actually edit it or create new items. And the user interface is pretty simple. What you do is you can just go down to where you want to add more. So say I want to add a little bit more to the assay format. I want to specify that the method used here is luciferase quantitation. And so I can add an item here. And I can say, okay, so I want to provide context regarding the assay method. And so it'll bring you this drop-down method of everything in the BARD dictionary. So you can select right here, assay method, no problem. Then you can add the value down here that you want to provide for context. So I can say luciferase, and there you go. So you're saying that you're using this reporter gene method luciferase induction, and that's exactly what we're talking about. So we click this, say save, and then it will have added it to the card, and it'll look just like this. And if you're all set with that, you can say back to context, and after a moment it'll show up on your assay definition page, no problem. Now you provided a little bit extra context, and that's the way you would build the entire assay definition from scratch if you had to do something like that for a project you were creating. You can also clone assay definitions from existing ones, so that way you can take some shortcuts. If there's already something very similar to something you've already created, it's much easier to clone an existing one, make some small changes, and then save it that way. Now, looking back at the project screen, you can actually see that we use the same interface for entering context items here, just like we did in the assay definition. And furthermore, the same interface is used for entering information for the experiments. So we can look at the experiments now. And for each experiment, you can also have context down here describing things like whether or not there was a concentration curve for a dose response, number of replicates, the activity threshold, things like that. And then we can actually look at what the data looks like for an experiment at the bottom. It'll take a second to load, but what you'll see is it's a list of experimental data just like you would see per compound in any other data storage for an experimental data. What's different is when you enter your data, you're provided with a list of terms from the BARD data dictionary that you have to select from, and once you select those, you can enter the value, and that way what you're doing is you're formatting the data in a way that everyone else will format it the same way if they're running a similar assay or a similar experiment. And this allows you to compare your results to other people's results or other two people's results much more easily than you could given existing free text only data repositories. So that is, of course, a very, very brief walkthrough of the functionality of BARD. In the future, we can go over a little bit more about how the controlled structure allows for better data mining and hypothesis generation, but for now, thank you very much for watching, and please enjoy BARD.